Testing, and welcome to another live stream that we're gonna perform today. We're gonna give it a second. We're gonna give some time for anyone that wants to join us today. Today we're gonna be talking about electrical testing on injectors and ignition coils. And let's see, let me just confirm that we have this going proper way. Okay, almost there. Okay, and we are live. Let's just confirm there. Okay. So in the meantime, I'm gonna search for a couple of turn this down a little bit. So I'm gonna search for a couple of vehicles that we're gonna be working on today. We have a the same Chevy truck that we were working with yesterday. We actually gonna review what we looked at yesterday, which was relays, very short review. And then we're going to use the same diagram to talk about injectors and ignition coils. Now, from there, we're also going to talk about this other vehicle. And the injectors on this vehicle are going to be pretty much the same. We're going to talk about conventional injection, okay? We're not going to talk about high pressure injectors. Not on this video. The circuitry is the same, but they are controlled in a different way, okay? Um, the voltage is it's higher. The aperture it's commanded at a higher voltage. They work in a different way. It opens up and then they hold the injector open at another voltage level, which is about battery voltage. But we're not going to see that today. Today I want to talk about injectors and coils. Injectors are the same on all the three vehicles that we're going to be looking at, but the coils are controlled in a different way. Ignition coils I'm talking about. For these other vehicle, we're going to talk about let's see, something older. Let's see, an '06 Escape. I'm pretty sure that 2006 Escape is gonna have it's gonna have the kind of coils that we need, because I rebuilt a lot of those computers. We rebuild those computers at the shop, and usually it's the what am I looking for? Right here. It's always the same problems with the ignition coils. Escape to two-wheel drive 3.0, and let's pull diagrams. Let's go to powertrain management, engine controls, and here's my other diagram. Okay, so this is gonna be one, that's gonna be another one, and this is gonna be the third one. So when when we talk about, we're gonna talk about, I think that the way I'm gonna be doing this, I'm gonna talk about the injectors, the circuitry, ignition coils, and then we're gonna move on to this simulator. See if we can use the simulator and see what we make out of that. Okay, so hopefully I can remember my password. Yep, that was it. Okay, we're gonna come into this simulator, and then we're gonna attempt these three levels. And after that, we're gonna talk about something that anyone from the audience wants to talk about. I mean, if you have any specific questions about certain type of testing, you can post it on the comments. And at that point, we're gonna start um, talking about that. Okay. So let's start. Let's just review what we saw yesterday, and that's gonna be, like I said, very quick, very fast review. Okay. We're talking about relays and relays. Let's let's see what we have. I mean, I remember we have two sides of it. One of them is the control side, which is this right here. Hopefully you can see it. Zoom in a little bit more. So this is the control side, and this right here is the load side, okay? So control side, that's how we control the relay. And the load side, that's the switch, the actual switching of the relay, okay? This is the switch that we're gonna control using this, okay? Remember, we have to get good ground and power for this thing to turn on and pull on this lever and close the circuit. So this is the control, that's the load. Whatever we have over here, we're gonna put over here. Okay, so that means that whenever we energize the relay, we're gonna close this switch, and fuse 20 is gonna supply voltage to this wire. The wire is gonna feed the pump, and since the pump has a good ground on the other side, this pump is going to run. Okay, so that's all we're going to be talking about relays today. We might find another relay to talk about on the electric simulator, but for this diagram, and that's it. Okay, we're not going to talk about that anymore. Let's go back to um, fuel injectors. Fuel injectors, as you can see, we have 8 injectors here because this is a V8 engine. Okay, we got 4 injectors per bank. So we have bank 1 and bank 2. On any V engine, we have bank 1 and bank 2. They're controlled separately. Okay, each bank has its own uh, O2 sensors or fuel air air fuel mixture sensors, whatever you have, and they're controlled independently. The computer controls them independently. Okay, that's a chat for different video. Today we're going to talk about electrical. How do we test uh, an injector? What's the electrical testing that needs to take place in order for you to determine if you have a bad injector, if you have a bad wire, a bad supply, if you have a bad control wire, if your computer is defective, if your connector is defective? That's what we're going to talk about. So, number one, let's see that all these injectors, all of them have this wire in common. Okay, General Motors is known for separating these injectors in two sets, like two banks, and we're gonna see that up there. See if it is what I'm thinking it is. Okay, and yes, as you can see, we got 4 on injector 1 and we have 4 on injector 2. These two fuses supply the power for the injectors to perform their function. Okay, so all of them get power from the fuse box, 4 from one fuse and the other 4 from the other fuse. When are these fuses hot? Right here, hot and run and start. That means whenever you have the key on the run position or the start position, that's when we get these fuses energized. Let me see, there's another wire right here. Where does that go to? Probably goes to auto sensors. Yes, no. No, they go to ignition coils. They go to the ignition coils. Okay, so we're gonna get to that in a second. Okay, so power goes in. Remember that the ignition coil, the injector, it's just a very long wire that it's winded on a core inside the injector itself. So this winding, it's uninterrupted, goes in, it goes through the core. I mean, inside the injector itself, and then let me zoom in here. So voltage goes in here like this, goes through the wire, through the coil, right? And that's a actually a coil, not an ignition coil, but this is a coil, a winding of wire. Goes out on the other wire, and that wire goes to your powertrain control module. So on your powertrain control module, we have, as you can see, injector 8 control. That means that every time the computer wants to fire this injector, it's going to pulse this wire. It's going to pulse it down to ground. And when we get that ground, right, ground is going to go all the way over here. And since we have power over here, this is going to become a magnet. The magnetic field is going to be generated, and that's going to pull on the pintle. It's going to pull up, right? And then the fuel that it's pushing against the pintle is going to spray into your combustion chamber. Okay, that's as far as I'm going to go into explain about AM performance. We're not going to talk about that here. That's the function of this injector. Every time we get ground and power on this side, this injector is gonna spray, it's gonna fire, it's gonna open. Okay, so the same applies for all the other ones. Okay, let's just follow this wire, and this wire goes to injector 7. Okay, you get the idea. All of them have a control wire that goes up to the computer, every single one of them. Okay, and the way the computer controls the injector is by grounding this wire. We're gonna see that once we get to the elected simulator right here. Okay, once we start seeing this, we're gonna see this in action. So what could be wrong? I mean, what kind of problems could you get in your shop? So let's say that you have an open circuit on this wire right here. What are you going to be reading? Well, depending where you are testing, right? If you're testing here and the open is here, you're going to be reading voltage. The voltage that goes in and out, you're gonna read it here. Whatever meter you're using to check, you're gonna be reading. Whatever you're reading here, you're gonna be reading here. Why is it that you read the same? Okay, why? Because the circuit is opened, right? And since the circuit is open, there is no ground that is provided here. So that means that there is no voltage drop. Whatever voltage is going in, it's going out all the way out to the open circuit. And that'll be if this control wire was grounded all the time. But since it's going to be pulsed down to ground, that means you will see, I mean, you still see the voltage here. Whenever this wire is good, I mean, that pulse, you should see it. You should see it here. You would see on your oscilloscope, you're gonna see a flat line at about battery voltage or charging voltage in this case, because most likely it's gonna be running. Your engine is gonna be running, and then you're gonna see the drop. You're gonna see that in a minute when we get to the simulator. So how do we test this? If we suspect that we have an injector problem, electrically testing, you're gonna bring your testing equipment, either a needle, a back probe, an adapter, whatever you're using to test this circuit. You want to get access to the metal conductor inside the wire. Okay, how do you do it? That's up to you. We do it in many different ways. Do we strip out the insulation? Yes, of course. Do we cut wires? Yes, we do. Do we back probe? Yeah, we do that. Do we pierce the wire? We do that too. Okay. Um, as long as you repair this intrusion that you do into the insulation, I think every single test is valid. Okay, that's up to you how you want to handle that. Between you and your customer, I mean, whatever they want to go for, that's how you handle that. So once you get access to these metal part, either the pin, the wire, whatever it is, you should see with the ignition on, remember, you should see good battery voltage, right? Or operating voltage, charging, whatever it is. but it should be high. Okay, and over here, if you're using your multimeter to test and the ignition is on, but the engine is not running, you should see pretty much the same voltage. Okay, same voltage here than here if you're using your multimeter. If you don't have an oscilloscope and you do this test, you can confirm that the coil is good and there's good continuity between this end and this end. I mean, we cannot read resistance. We don't know how much amperage is going to draw. I mean, we don't know anything. The only thing we know is that if we read the if the voltage that goes in, we can read it out here. That means this winding is good. Okay. Now, if we disconnect this connector, the connector, uh, and the voltage goes away, that means that confirms that the voltage that was going in was the voltage that we were reading. Okay. That's a test that you can do. Now, if we come all the way to the computer, okay, you should read the same. Whatever you read over here on this point, you should read over here. I highly recommend you guys doing electrical diagnosis. You'll invest in a good oscilloscope. I mean, it doesn't have to be like anything fancy. I mean, there is a lot of options out there, especially these days. I mean, PC-based oscilloscopes is what I highly recommend because they're easier to use. Some handheld devices, I have a couple of them, and I use them occasionally, especially when I'm working on my bench. Okay, when I'm rebuilding computers, rebuilding instrument clusters, or ABS modules, when we cloning, when we are diagnosing controllers on bench, uh, I don't use my PC based. I use my handheld. I have an OTC, and the other one I don't even know what brand the other one's. The other one's Chinese, one of those knockoff brands. But anyways, invest in a good oscilloscope because you're gonna need it. Okay, when you're testing, you're gonna need it. And again, once we get here, I'm gonna show you how you use that oscilloscope. Okay, you hook it up here, and then on the ignition on or start position of the key, these voltage should be there, right? If you're measuring with the multimeter, it should be high. Your multimeter might start to flicker a little bit once it starts running because of the drop, right? The drop of the control from the computer. And if you have an oscilloscope, you will get a pattern, right? I mean, it's going to be flat at about battery voltage, and it's going to drop down. Now, if you're testing with an oscilloscope, it's important that the drop, right, when it drops, it goes all the way down to ground, close to 0 volts. Okay, a few millivolts above ground level, it's acceptable, but it's gotta be very close to ground. Okay, that means the computer it's capable of grounding that injector. If you only see it and it drops down to about 5 volts because you have a background, and those 7 volts, the difference between operating voltage and the drop to 5, which is going to be about 7 volts, it might open up the injector, it might not. It depends on the voltage, right? But let's exaggerate a little bit. Let's say that it drops down to 8 volts. That's not going to open up the injector, okay? So you want to see that the drop goes all the way down to 0, goes moves forward and then goes back up, and you see that spike, right? The spike that is generated is because of the collapse of the magnetic field that was created when this thing was energized. Okay, that's how it is. You want to see that. Now, what could you see if we have an open on the control wire? If you hook up your oscilloscope here, you might see some kind of bias voltage or diagnostic voltage, which means that you might see like a point A, 1.8, 2.2 volts in here, which is a voltage that the computer puts out for diagnostic purposes, right? If you, let's say that you see here like 1.2 volts, and over here you get 12 volts, um, that means you have an open right here. Okay, unless you have something else, some weird stuff. I mean, someone shorted out a bunch of wires, and now this one's cat and this one's shorting this out. Those are very rare circumstances. So good voltage here, no voltage here, that means there's an open. Voltage goes in, nothing comes out, or you see the bias voltage here, that means you have a bad injector or bad connector, right? What other scenario? Voltage here, no. No voltage here, but we have voltage on these. I mean, the engine runs, and we have a code for injector circuit 8, and there is no voltage here. Are we gonna go check our fuses? On this particular vehicle, we might go to the fuse box because I want to show you the splice. The splice goes all the way up to the fuse box, but not on the fuse. It goes to the connector, right? It splices out of this pin D10, if I'm not mistaken. Are we gonna check the fuse? No, we're not gonna check the fuse. Why? Because the engine runs with the other 7 injectors. Okay, so that means the fuse is good. All the other 7 wires are good. If the other wires are good, and this one doesn't show any voltage, we have an open right here. Now, let's say that on this particular vehicle, we have an engine that tries to fire and run on 4 cylinders. Okay, 4 of them don't run. 1, 2, 3, and 4 are firing, but 5, 6, 7, and 8 are not. Most likely what? Bad fuse, right? It's going to be really hard for these 4 wires to be interrupted. So we might have a bad fuse. We might have a bad connector at the fuse box. Okay, something related to these particular wires. Okay, either these or the other ones. So those are the scenarios where you're gonna be working with. If someone has any questions about them, you can post them on the chat. I have a question here. Is it normal for GMC caddies to leak rain? Mm, I've seen my share of problems. I don't know. I don't know how to answer that question. I mean, this chat is not about that. This chat, trying to keep it on electrical testing. So I'm not gonna be able to answer that question. I mean, I don't know if it's normal or not. Um, I can tell you it's normal for Acadias to act up on timing chains. I've seen a lot of those. That's for sure. That's something common on those. But not even that's electrical. Okay, so let's not talk about that. So those are the injectors. That's the way you test the circuitry. There is a couple of more tests that you can do, and that'll be to check for the amperage that I mean the current that the injector is using. Okay, that goes hand to hand with the voltage going in and the resistance of the injector itself and how good the ground is. Okay, so uh, those three things play a big role when we're talking about current flow. Okay, but here's the thing: if you have a way to let's say you have a way to remove these fuse and install a jumper wire in here, and then you can hook up a an amperage reader, and then you see all your 4 ramps like firing, and all of them are at the same time. You forget about any other testing. I mean, those 4 injectors are firing all the same, using the same current at the same level. That means the 4 of them are being commanded the same way. All of them get the same voltage. All of them have the same resistance, and the computer is grounding all of them at the same level. Okay, that's how much you can see by just measuring amperage the fuse. Okay, for that you need an oscilloscope and an amperage clamp. Okay, so that's it. That's gonna be it. One more test. One more resistance. It's good practice to measure the resistance and make sure that it's within specs. Okay. Um, it, When we're talking about a resistance, we're talking about the resistance of the coil itself inside the injector. So you disconnect this right here. You disconnect this right here, and then you measure from here to here. Okay. Um, um, the resistance should be equal and within specs. So we're gonna move over to our ignition coils. Ignition coils. At the beginning of this chat on this diagram, we saw the wire that came from the injectors, and it's the same that fits the ignition coils. Okay, and if I'm not mistaken, it was this one and this one. Okay, as you can see, all of them feed power to my ignition coils, just like that. One, two, three, four, five, six, seven, eight. Okay. So ignition coils on this particular vehicle, we have these wires that share between the are shared between ignition coils, and let's say that we don't know what they are, and we're trying to figure out what they are. We're gonna see if we could, by process of elimination, determine what these wires are. Okay. Let's restore this. Let's see if we can tell which wire is what, okay? Number one, we get here a symbol for ground, okay? We get a symbol of ground, and it's shared among all of them, okay? So this pin A, black wire, is gonna be your ground. That ground needs to be good and load tested. Okay, load tested, we talked about that yesterday. Okay, these wires need to be able to carry current. If you test it with a multimeter, that's not a good test. If you do a resistance check between these point and ground, and it says something close to 0 ohms, it's still not a valid test unless it's loaded. Loaded, I'm talking about you using the wire to supply uh, current to a component, okay? And that component performs a function and pulls current through the wire, and that means it's a good test. If other than that, sometimes we don't have the equipment, or we don't have anything to test it with, and in that case, we check it. If it's ground, it's ground. Otherwise, um, oh, there is a way to test it. I mean, if you have multimeter, you actually fired it, right? I mean, you make that you turn that component on. If it's got a switch, you turn it on, and then you check for the ground right here. I mean, whatever ground was there when you turn it on, it should remain. Okay, that's how you do a load test. So by process of elimination, this is our ground among all of them. This is another ground right here, redundant, right? Okay, for the other ones, okay. We're not gonna highlight it because it gets um, it gets in the way. So that's one of the wires. Now, what about these other wire? What is this wire? This wire is also what? Shared, right? And this is our reference load for the coils. Okay, let's talk about this. Imagine this, just like another ground. This is the and this is a circuit that is used for reference. Okay, and it's low, so that's not our signal, that's our reference low, and it goes to the computer. Okay, that's going to be the same on all of them. um, with next wire, this wire this wire is not shared. It goes up to the right, and it goes to pin 26. What's that? That is our control wire. That's how the computer controls the ignition coil. What type of control are we gonna have in there? Are we gonna have like a drop all the way down to ground like we had on the injectors? No, we're most likely gonna see a pulse, something close to about 5 volts, and that pulse is gonna be from the computer, triggering the coil itself. Okay, one one quick tip. Okay, when you see all this bunch of wires on an ignition coil, you got more than three wires, like three or more. That means um, the um, the ignition coil is the one that performs uh, the potency. Like it's the one that handles all the current to fire that spark. Okay, everything happens inside the ignition coil. All the computer does is just puts the signal and it tells the coil when to fire. Okay, and by process of elimination, we determine that this is our signal wire. So since we have our ground, our reference low, our control wire, and we need power to make this work, well, guess what is this? That's the wire that comes from the fuse, right? Okay, so those are the wires that go into this ignition coil. Now, how do we test it? We want to make sure that we have good power, we have good control. This is going to be really hard for you to see unless you have an oscilloscope. Okay, I don't even know of an effective way to look at this without an oscilloscope. There are some tools that you rest on top of the coil, but if all you have is it's that tool, it'll tell you if the ignition coil is firing or not, but it will not tell you why. If it's not firing, it will not tell you why. And right here with an oscilloscope, you should be able to see that control wire um, sending that signal to generate spark. Okay, inside the ignition coil, you have transistor that gets the signal, and then it grounds the coil, and then let's go, and then the magnetic field collapses from the primary into the secondary. Voltage goes very high, and since it goes high, it wants to go to ground, and the only path that it finds is through the spark plug, and that's when you get that spark. Trust me on that one. Okay. Uh, those are the wires for the injector. If I mean for the ignition coil, this one goes to the spark plug. So good power, good control, good reference low, and good ground. You want to make sure that those are good. If you're missing one, uh, go back to the origin of that circuit and figure out what is it that you're missing. If you're missing your control here, but you have it over here, which you might not have because the computer is detecting an open circuit, and let's say that you have an open circuit, the computer might detect it and not fire it. Okay, at that point, how would you handle that? Well, you could probably just measure resistance between this and this end down here on your ignition coil. You could do a resistance measurement. um, Other than that, the testing, it's pretty much the same as for the injector. You want to have good power, good ground, and good control. This is for conventional injectors on low pressure systems. I'm talking about low pressure, like let's say 60 pounds, right? Like let's make it on the safe side. Let's say less than 70 pounds, right? These are not high pressure injectors. Okay, they work with 12 volts. So we're gonna move on to another vehicle, and for this vehicle, it's pretty much the same setup. Okay, and by process of elimination, okay, what is this? This is my power. This is my power feed. How do I know? I could tell you because I looked it up before, and because it says battery plus, but that's not how I know. The reason how the way I know is because of this wire. If you use this wire, and this is a noise filter, this is just a capacitor, right? Capacitors have a polarity, and one thing we can see is that it's grounded on this end. So that makes this your power. This is your power feed, okay? We can follow it. It'll go to a fuse or some sort of relay somewhere. Right there, injector fuse. Okay, so that's your feed, your voltage. What about this wire? Okay, let's highlight it. It's shared and it goes back this way. And before we follow that, we're gonna eliminate another wire. We're gonna go to that one in a second. We got a ground symbol. That means this is your ground. Okay, so we have voltage on 1, ground on 4. Okay, now let's talk about this particular wire, the one that goes to the right. It is shared and it goes back to the computer, and it says IGF. And that is a monitor. Okay, that's a monitor for the computer to monitor the operation of all these 6 injectors. I mean ignition coils. Okay, so you might want to ask, why is it that we have only one wire for monitor and 6 different coils, and the computer actually knows which coil fires and which one doesn't fire with a single wire by doing the following. The computer knows when it fires ignition 6, okay? And as soon as it fires this, it wants to see a response on the wire, okay? If the computer fired up ignition 6, but it didn't see the response, it'll say that there's a problem with the ignition coil. That's how that works, okay? So by process of elimination, the other wire that is left, that's gonna be our control wire, and that works pretty much the same as the previous diagram. That's gonna be this one right here. That wire runs back to the computer, not this one, blue and red, runs back to the computer, and that's the control for that particular ignition coil. In this case, it's going to be ignition coil number 3. What about injectors on this vehicle? Well, they operate exactly the same, if I'm not mistaken, unless there is something weird about this vehicle that I picked. Let me go back and where are my injectors? Oh, right here, right here. So just like the other diagram, we have a common, okay, that is shared among all the injectors. And if you guessed that this is your voltage feed, you're 100% correct. Okay, we're not even going to go see this wire where this goes. We are expecting these to be a 12-volt feed. Okay, and that's pretty much what it's going to be, just to make sure that we're not talking nonsense. Okay, yes, injector right there. That was the other wire that came out of that splice. Okay, and that's the feed, the battery positive. Now the other wire is the one that runs back to the computer. That's going to be the control. This is going to be the control for injector number 6, and it works on the same principle as the other diagram. So we're going to move to this other diagram, which is also different on the ignition coils. Okay, and let me show you what we have here. We have ignition coils that look pretty much the same as the fuel injectors. They're wired pretty much the same as the fuel injectors, okay, with the shared power feed, okay. Actually, it comes out of the same wire. Look at this. You see? The same wire that fits in ignition coils, it fits fuel injectors. So if you ever find yourself where you don't have power on fuel injectors nor your ignition coils, most likely you have a problem with your fuse or your fuse box, or this wire is compromised. Okay, so this one works exactly the same as the fuel injector. This wire goes back to the computer. That's a control wire for the ignition coil. It's labeled DSF, A, B, C, D, E, F. That's gonna be 5, right? Yes or no? A, B, C, D, E, F. No, that's 6. Sure. Okay, C, D, F. That's a control wire for the ignition coil. How do you test it? You test it pretty much the same as the fuel injector. You might see some different waveform, a little bit different on the spike, especially, but pretty much the same. Okay, so that's gonna be all we're gonna talk about electrical testing on injectors and ignition coils. We're gonna move on to the electric simulator, and we're gonna start on level 1. Hopefully we can solve it today. Remember, this is free, and if you wanna use it, all you gotta do is go to simulatorelectric.com. This is a really good simulator. I mean, we're gonna pull our tools: instrument panel, oscilloscope, breakout box, diagnostic system, and our handy wiring diagram. So let's see what the work order says. Um, this want to know, so use the tools from the left. Want to know more? Watch the video. This vehicle has no malfunction. However, the vehicle shown in game mode will have a fault. Why is it that it's giving me? Oh, because I'm not signed in. Let's sign in so we can. Okay, start level 1. Not now. Welcome to level 1. The engine does not run. Okay, and let's see, instrument panel, oscilloscope, that, and that. Okay, let's confirm that it doesn't run. It doesn't even one try. Okay, so on a regular basis, on a real life application, what do we do? Well, we can test for spark. We could test for injection control. We could identify the vehicle, see if it communicates. We're pulling a VIN, right? So that means something is communicating. We're gonna go in there, read fault codes. Okay, what do we have? Injector circuit open on cylinder 1, 2, 3, and 4. Okay, fuel pump secondary circuit low. ECM power relay control circuit open. ECM power relay sense circuit low. So I hope I don't have to eat my words, but that looks very easy. Okay, so let's look at the diagram. We have injectors, and this thing has injector codes for all 4 of them. So 1, 2, 3, 4. There is no voltage here. I can tell you, computer cannot read anything here. Why? It'll be hard for all of these wires to be messed up. So most likely the origin of that thing, that's what is affected. Okay, so fuse 2, I'm pretty sure is not gonna have any power. Okay, besides the codes for the injectors, we also have 2 more codes. And let's concentrate on this one. ECM power relay control circuit open. So this is my power relay, my main relay, right? And yesterday we were talking about how relay works. And like I said at the beginning, we're not going to talk about relays on the diagrams anymore. But over here we're gonna stay we're gonna stay on top of that. So this wire, how do we test it? Remember, voltage goes in, goes through the winding, and goes out, and we should have voltage all the way out here on pin number 8 of that computer. So let's see. We're gonna hook up our, oh shit. Let's hook up our breakout box. Turn on my not a multimeter, oscilloscope, okay? And then go to pin number 8, okay? Ignition off. Pin number 8, we have 1 voltage, 1 volt per division. So we want to see 5 volts. So we have 5, 10, something around 12 is going to be around here. Hopefully you can see my cursor over there in the middle of the oscilloscope. Okay, and what else? There we go. Let's turn the ignition on. Okay, turn the ignition off. It goes down to ground, and then turn the ignition on, and we get battery voltage. What does that mean? Well, it means that this is good, this is good, this is good, and my wire is good. Okay? So the computer is not grounding this wire. Why is it? Let's figure it out. What does the computer need to be able to ground that particular wire? Well, number one, it needs a good ground to be able to pull these to ground. So we're gonna test very quick our grounds on these PCM. And if I'm not mistaken, we only have two in here, which is 3 and 37. So we're gonna go to pin number 3, and it's low. Okay. And the other one's gonna be on 37. Nothing to do. Okay. So both of them remained very low, close to ground. We have good voltage. Let me bring this to the center. We have good voltage all the way here, okay? And we're gonna do a final test, which is gonna be to monitor this wire while we remove this relay, okay? So that's gonna be on pin number 8 while we remove K2. Okay, and we're gonna pull K2. Okay, so the voltage drops, as you can see on the oscilloscope, and that's because we're interrupting this circuit right here. So the voltage that we can see on my oscilloscope actually comes from the relay, or from the other side of the relay. Let's plug it back in. There you go. It goes back high. Okay, so at this point, I would recommend my customer to replace a computer. It's really hard to call out a computer, especially, I mean, this one's easy. I mean, over here, I mean, if you make a mistake, all you got to do is just uh, move on to the next level. On the real life, some of these computers are near $1,000, $1,500. Some of them are $2,000. Okay, so on the real life, you would really want to make sure that you check everything. Okay, so what else do we need in order for this computer to pull this thing down to ground? We need uh, an ignition supply, but the computer communicates and it's alive. I don't know on this simulator, but on real life, if the computer communicates, that means you have good ignition, right? I mean, because ignition is the one that wakes it up. And since the computer communicates, I want to say my ignition supply is good. Hopefully, and I think it's this one, but we're going to test it anyway. So that's going to be on pin number 26. Hopefully, we can get it from here without moving much. There you go. Ignition is good. And that's not even my ignition. That's my that's my battery. So that's F6. Where's my ignition? Do we have an ignition supply? Do we have an ignition supply? We don't have an ignition. Nothing here. This is my battery, like we saw. These are my communication. All of these are for the injectors, ignition coils, couple of solenoids, monitor for this, monitor for, no, this is not a monitor, this is a feed that goes in here. Now it's a monitor for this feed, I think. Another feed, another monitor. I don't think we have an ignition wire here. And the computer communicates, so I don't think we have a problem there. Okay, so we're going to recommend replacement of these PCM. And let's go ahead and do that. We're going to turn the ignition off. We're going to disconnect it. We're going to bring it over here into my removed parts. We're going to replace it, hopefully, because otherwise, if this was the real life, you as a technician will have to pay for that thing. And we're going to plug it back in and cross our fingers, turn the ignition on, and go to pin 8, right? Yes, I'm busy a little bit. No. So, and it's not, it's still high. What did I miss? What did I miss? Do I still need to program this thing? I think I still need to program it. But that thing should be, that computer should be able to pull that to ground. Yeah, look at that. It was the programming. Okay, so there you go. This thing runs. Okay, so it was, yes, it was in fact the PCM, but um, it needed to be programmed. Okay, so when we replace a controller, you need to program it. Let's see, configuration. We might need to do idle relearn, still relearn. Yes, we're relearning. Okay, and that's it. Let's go check for fault codes. We have some fault codes still. We're gonna clear them. Turn the ignition off. Go back out. Turn the ignition on. Read fault codes again. No fault codes. I think we fixed this part. I think we fixed this part. Okay. So we're gonna put this away. Return my tools. Accept my work order. Reconnect my computer. Make sure everything is in place, and the note is going to be we found and replaced a defective PCM and programmed right now. Who cares? Uh, you saw me. You saw me returning all the tools and erasing all the codes. I don't know what they want. So let's go back to level 2. The engine runs irregularly. Hopefully we can get it done. Yesterday I couldn't complete that other assignment because I was tired and I wanted to go to sleep. It was late, and oh, just like today, I said I was gonna be here for 2 hours. I mean for 30 minutes, and it's been almost an hour. So let's see. This engine runs irregularly. We're gonna pull our instrument cluster, oscilloscope, diagnostic system, breakout box, and wiring diagram. Let's see. Looks like the engine it's misfiring. It should identify since it's running, so well, sometimes they don't, right? Let's read fault codes. O2 sensor circuit, low voltage. System 2 lean, O2 sensor circuit, no activity detected. Okay, so let's see. Go to systems, engine management, live data. We're gonna see our short and long terms. I really don't like to do performance diagnosis anymore. I try to stay away from that, but I still remember a couple things from back in the day. So let's see. Short term, this thing is not even correcting right now. Why? Because it's got a fault. So we're not even going to see. We don't have access to this at the moment. We're going to go see our O2 sensor. O2 sensor. We want to make sure that we don't have a fuel issue here. And it doesn't seem to be the case. So let's go after what I was testing for right there. It's making sure that the engine is able to rev up. Just when you have a fuel problem, you cannot achieve that. Well, sometimes you can, but sometimes you cannot. Let's connect my my oscilloscope to the ground. On. We want to see 5 volts. Like no, this one we want to see less. This is going to be 200 per division, 500 per division. We're expecting to see some very low voltage here. If anything, we're going to be reading less than 1 volt. And that is going to be read on, if I'm not mistaken, this is a ground. So it's going to be on pin number 3. That's going to be on this center pin right here. Come on. Good. So we're reading about 1 volt. I mean 0.1 of a volt. Nope. And we want to make sure that we have good ground. We want to make sure that the heater operates. And that's going to be my orange wire. So it's going to be ground, should be ground, good. And that should have voltage. We don't have any power there. We don't have voltage on this blue wire, and I think that's a problem because if my filter doesn't perform, the O2 sensor doesn't perform. So what do we have on this splice? We have my fuel pump, and if you can hear in the background, this engine is running and it runs really strong. So that means this fuel pump is good and it's properly energized. So up this way, I don't think we have any issues, okay? I don't think we have a code for this monitor. Let me go take a look at my let me go take a look here. see if we have any codes for anything related to the monitor. Fault codes. Auto control system RPM lower than expected. Of course, why not? No codes for that monitor. So I'm going to replace this wire. I'm going to replace this wire right here. And voila, we have our voltage back. And let's see if my O2 sensor is switching now. Which wire was it? That was on the black one. Okay, now it's oscillating. Let's right there. Let's see it in action. Not only that, my short term is correcting, my long term is correcting, and my oxygen sensor output it's switching high and low. Okay, that fixes this vehicle for sure. Let's turn it off. Ignition on. Engine management, fault codes, and clear fault codes. Let's crank it up again. Make sure we don't have a check engine light. Nothing to do with that lower than expected RPM. Okay, seems to be that it's good. Turn it off. And how did we fix this car? By we found and replaced a broken wire at the O2 sensor. Okay, and failure resolved. Blah blah blah. You know what? Every time I do this, I just get a message that says that I need to return the tools and all that. And since this is not even a competition, from now on, I'm just gonna return it to the customer. Yeah, I know. I always get that kind of message anyways. Okay. There is an unknown problem. This is the final. This vehicle has a problem that we have to identify. And let's see what it is. Okay. Let's crank it up. Okay, engine runs. Let's see if it communicates. Communicates. Let's see if my engine has any fault codes. I'll be damned. Again, crankshaft position circuit. Crankshaft position sensor circuit range performance. Okay. So these are the kind of codes that take you out for a loop. All of them are in memory. Okay, at a point that was a problem, but not now. So okay, so it says no O2 sensor activity. Let's go check our live data for our short, our long term, and my O2 sensor output. See what they say. But that is true, yeah. No activity on the O2 sensor. Okay. But it responds. If we go high, it goes up to 0.8. Let's see what we have in here. low as I can have it. Forgot to connect my oscilloscope. Okay, let's go check what we were testing before. Good. Power on that wire. This is pretty much the same as the other one. Good power. Good ground. That's my heater. Good ground and no activity. What happened? Alright, if it's not correcting, why is it doing that? Okay, let's turn it back off. Is this a field related issue? Doesn't seem to be. I think it's more like an O2 sensor problem. Let's just check my math while this thing is running. Point 3. 4.3, and we have 3 grams per second at roughly 900 RPMs. Looks a little bit out of spec. This ain't gonna be easy. So 800 RPM, 3 grams per second. This is gonna be, man, I wish I knew. Oxygen sensor, it's very low. Okay, what do you guys think? Whoever's watching, what do you think? What do you think we have going on here? Is it my O2 sensor? My O2 sensor at higher RPM should be able to read, even if it's not. Okay, what do we get there? Look at my auto sensor, it's very low. Even if we rev it up. It remains low. It's got a good ground. I feel tempted about putting an O2 sensor on this thing. You know what? I'm gonna put an O2 sensor on this thing. I think we have a problem with the math or with the O2 sensor. Should we check let's just make sure it's get a good ground at least. Good ground and good power. Where's my math on this diagram? Accelerator, that's my math. Uh, green is going to be ground, and then some kind of voltage, and then the signal. Let's go after that. I mean, it gets hard sometimes. Not all of them are that easy. So on the map, we should have, I think, good ground on the green one. Let's crank this up. So it'll be a good test. No, that's gonna be my power. Oh, that's good ground. That's good ground right there. Okay. So it is a ground because it's the same ground that fits my O2 sensor. Okay, and this cannot be powered. This is a ground for the O2 sensor, so it is connected here. So since the map it's connected to that splice 2, that should be a ground. Pin number 3 is a ground. Pin number 1 should be 5 or 12. We got 5. And the other one's gonna be my signal. We got 0.9. Let's go to the computer, let's go to the scanner and make sure that it's the same voltage that we see. I don't have a data pit or map. Shoot. So, but let's see what we read on my grams per second. That's going to be 10, which is this right here. Let's see what it gets to when we snap it. Fell its face. Okay, we're gonna put an auto sensor on this thing, and hopefully we don't have to eat that part. Blow that engine. Yeah, that didn't correct nothing. So that was not the problem. So I just became a parts changer for today. Do we do that sometimes in the shop? Yep. Man, I don't think we have a fuel problem. Let me just plug in a fuel pressure gauge and crank it up. Nope. Fuel gauge good. Fuel gauge good. Could have been my math, but it responds. So since I'm just acting as a part changer today, which is what I am, we're gonna replace the math. Okay, and Codes should not keep this from working, even if we have full codes. Okay, what's going on with this thing? O2 sensor reads low all the time. It's got a good power. So that's my heater, 90 millivolts. That shouldn't keep it from working. We got 12 volts right there. We have good ground. There. And we got no activity here. This thing doesn't want to stay there. There we go. Now what I can see is that I got like 90 millivolts in there, but I don't think that's a problem. I don't think that's a problem. That's the ground for the O2 for the heater, which is this one right here. Yeah, that was not a problem. Not a millivolts. It's just the voltage across that component. Voltage drop. It's that's what it is. So let's all codes. System too lean. PO 171. What else can generate a PO 171? We have good battery. I mean, good fuel pump. Besides the fuel pump, we have a freshly replaced MAF sensor with good power, good ground, and good signal. 12 volts. What? That's 12 millivolts. I said 12 volts. No, not 12 volts. 5 volts and my signal, which is what else could be causing that with no codes? A bad throttle plate. Could that be causing that? So leaning out the mixture, yes, could be. So programming, we don't have anything to program here. Latest version. So my throttle plate, that could be excessively opened. And well, let's go check. It's gonna be 5 and 10. It's gonna be the supply for my throttle body. So that's gonna be right here. Black is gonna be 1. We should have power there. Okay, and then 5 is gonna be my ground, which is there. We should have data. That's gonna be my can on pin number 4. That's my can low. Okay, can low. Let's see if we can appreciate it here. Looks like a good package of information. Next one should be can high. She's just the opposite. And since we have, let's see, put it to 1 volt. And we got 1, 2, 2.5. Yes, that looks okay. Well, based on the symptoms, we put a new sensor on this thing and new muff. Okay, so I'm gonna replace my throttle body just because I'm thinking that it could have a problem with the plate. Okay, for that, I'm gonna turn the ignition off, disconnect it, replace it, and install it. Okay, turn it on. Perform a calibration configuration TBMC. Let's relearn it because we just replaced it. We go back, check for fault codes, clear them out, off, on, still no good. That is so weird. Let's see, engine management. What fault codes do we get on? System tooling. Yeah, we don't have this one's in memory. These are active. My system's tooling. Yes, I see that. I cannot think of anything else that could be causing this. I mean, on an actual engine, there is a lot of things that could be a problem, right? Um, we could have an open purge valve that is feeding oxygen. We have an air leak that it's also feeding oxygen. We could have a low fuel pump that it's not delivering the amount of pressure and thus leading out the mixture. All of those things could cause a PO171, a lean code. Uh, on this one, if I ever tell you why is it that I stopped doing performance diagnostics, this is one of the reasons. Um, okay, electrically seems to be okay. My O2 sensor has good heater, good ground. Okay, my map has good 5, good ground, good signal. I'm not able to convert the voltage and see it with my scanner. Like I cannot see. I can read the voltage, but I don't know what the scanner sees as a voltage. I can see the activity as grams per second, but that's about it. Um, a stock open EGR, I'm pretty sure it should be. Oh, there, look at this. A stock open EGR should be reaching out the mixture. What do we have here? This is my canister perch sauna. What if it's open? Where's that thing at? Uh, Gray and blue. That's gonna be this guy right here. Let me just check very quick, making sure it's not commanded on. It's got 13. It's got 13 volts, right? And 13 volts. That means it's not commanded on. You know what? Okay, let's disconnect, remove it, and we should have seen something here. Change on RPM, and we didn't. Hey, look at that. Look at that. That's what it was. I'm pretty sure. Okay, parts changer. I think you found it. Yep. That was a stock open purge valve. After replacing, I was about to replace the PCM. After replacing an O2 sensor, let's go back to data. Okay, live data. Let's see what we have. Well, now it's correcting. The mounting sensor is actually switching. Okay, so this thing is fixed. Damn, that was hard. All codes. Hopefully, these are new code. These are the off. These are memory. But let's turn the ignition off, on, clear the codes, go back, read again. No fault codes. Live data. This thing should be running. Yeah, I think it runs good now. Here my auto sensor is switching now. Yeah, I think this car is fixed. This was a hard one. Threw it for a loop for a minute. But it was it's fixed. Okay, so we're gonna turn the engine off. And we're gonna feel our work order. Should we say that we changed parts that we didn't have to? No, we found and replaced the stock open perch valve. Sure. After spending money on an O2 sensor that we didn't have to, and also throttle body that we didn't have to. Return the vehicle to the customer. Yes, I know about all the tools, but I always get that error code. Okay, so that was it. This one was hard. So I see a couple of people in there. And if you guys have any questions about anything specific and you want to talk about, I'll be happy to answer your questions. Other than that, I'm gonna be going away for today. It's an hour and a half. It was from 8 to 9:30. I'm not gonna be streaming back until probably Sunday. Okay, so if anyone wants to watch this again, we're gonna talk about probably communication networks on Sunday, and again we're gonna try the elected simulator. So no questions. Thank you very much for watching. We'll see you on the next one.